Hello everyone, good afternoon. I'm Ayse Balaban and I'm coming from the University of Greenwich. And actually this work is collaboration within the 9 Eylül University, which is in Turkey. And today I'm going to talk about the usage of some specific types of nanomaterials in carbon epoxy composites in order to improve their material properties. So basically this study is a quite preliminary study, so of course there is a lot of future work, but this part that I will be explaining is just like the beginning of an extended research. So sorry, I'm gonna start my presentation by explaining the aim of the study, so what is the motivation of it, and then I'm gonna explain the introduction of it. Then I will talk about the experimental testing because I will be presenting the experimental testing part only. And I will talk about the results and discussions. After that, I'm going to conclude my presentation with giving some ideas about the future work of this presentation. So basically, if you look at the title, it is quite obvious the aim of the study, but basically the aim of the study is in order to manufacture different types of composite materials with carbon fiber epoxies and using the same materials with different types of epoxies with carbon nanotubes in order to enhance the material properties, and then in order to compare the material properties with the ones with carbon nanotubes and with the ones that without the carbon nanotubes. So after this study, we will be able to determine the strength and effects of the carbon nanotubes, and then so this study also includes the tensile strength and flexural strength of the materials. So the motivation of the study is obviously the high usage of composite materials in general in different industries, especially in defense industry or marine industry or automotive industries. But for the carbon epoxy ones, they are mostly used in, again, like aerospace engineering, in not marine engineering, but in some civil engineering applications, etc., etc. So they are becoming popular every day. But although there are like a lot of research, but still it is quite important to know us about the material properties and know about the behaviors of the carbon epoxies under specific loading conditions. And if we are using some like additive materials or additives such as like carbon nanotubes, for instance, or like different types of nanomaterials, we need to know the effects of the usage of these type of additives on the composite materials. So on the other hand, even there are like different parameters that might affect the material properties, of course, even like the manufacturing methods, etc. So still, although there are a lot of research, but still there are a lot of way to go in order to understand us what is going on. So again, in literature, there are some research using the carbon nanotubes, and there are different techniques in order to investigate the material properties with the carbon epoxies with carbon nanotubes. But in our research, actually, we used a specific epoxy with highly concentrated carbon nanotubes, and we mixed these type of epoxy with the neat epoxy resin, and then we also manufactured any other materials without the carbon nanotubes. So I'm going to explain you with this table. So basically, in this research, I will be presenting you four different types of materials by using two different types of carbon fiber cloths. So the difference between the first bunch and the second bunch are the only densities of the carbon fiber cloths. So we used carbon fiber cloths in order to manufacture it, and for the neat resin we used this EL2 epoxy neat resin for all the manufacturing, all these four different types of materials. The difference between them and the bit that we will be talking about, the carbon nanotubes, is with the second material and the fourth material. So we used Epoxy 12806 carbon nanotubes, which is a kind of liquid epoxy resin with highly concentrated carbon nanotubes. So this is a kind of material that was manufactured in Belgium by Nanomaterials company, and then this was designed in order to decrease the delamination effects of carbon epoxy composites specifically. So again, if we can understand the effects of the delamination and etc. in the future, so it will be quite novel new contribution to the literature. So basically we started to manufacture the material, so we completed the manufacturing in University of in 9 Eylül University, and then after the manufacturing part we ran the experiments in University of Greenwich. So the first one and the first material and the second material, actually all the materials that we manufactured were used vacuum infusion technique. So actually we started to manufacture them with the hand layout ones, and if you check the abstracts, actually it says that it's the hand layout technique. But after some experiments, unfortunately we saw that the hand layout technique is not quite effective for this type of material. So then we switched to the vacuum infusion technique, which allowed us more homogeneous results for the composite materials. So although again for the hand layout techniques we were able to get some results, but the standard the relation was not quite similar or was not quite satisfying. So yes, we used the epoxy neat resin for the all manufacturings, and it is EL160 neat resin with the density of 1.15 gram per centimeter cubes, and then we use the same hardener for the same brand, and then the density was like 0.96 gram per centimeter cubes, and then the hardener ratio was 100 to 35. So this bit that we used for the material 1 and material 2 with active carbon nanotubes. For the ones with the additive ones, we used the carbon nanotubes, as I said before, the Epoxy 1 with the density of 1.1 gram per centimeter cube, and it was mixed with the neat resin, which is this one again, by the ratio of 6 to 1 by weight. So yeah, the difference between these material 1 and 2 and 3 and 4 are the only densities of the carbon fiber cubes, and then after manufacturing them in Turkey. As I said, we ran the experiments in the UK. So basically we created a small, we started to manufacture the small pieces rather than the big ones in order for us to learn how to deal with the liquids or the carbon nanotube ones actually. So the perfect size was for us was 40 centimeter by 50 centimeter, and then again all the manufacturing process was including the vacuum infusion technique, and then the epoxy mixtures in every time it was slowly infused to the vacuum bag, and then for each specimens we used like 4 layers of carbon cloths. And then after that, all the materials, they were cured at room temperature at first, but then they were cured at 80 centigrade degrees for 8 hours, including all the ones with or without nanomaterials. So for the experimental testing, we ran the tensile testing and the 3-point bending testing in order to estimate the tensile strength and the flexural strength of the materials. So at least 5 of the specimens for each material was tested, and then all the experiments they were run according to the ASTM standards, and then all the span lengths and all the tensile testing and 3-point bending specimen dimensions were chosen according to the ASTM standards. So through the experiments, through the experiments, for the tensile testing, all the elongation and force values were recorded in order to estimate the tensile strength. And then all the tests were at the room temperature, and the universal testing machine's crosshead was 2 millimeters per minute. Similarly, for the 3-point bending test, again we used the same universal testing machine in Greenwich, and all the experimental procedure was according to the ASTM standards too. Again, 5 specimens were tested minimum, and then they were all in a good agreement between them. And then this time the crosshead speed was chosen as 1 millimeter per minute in order for us to estimate the flexural behavior of the materials through the testing. Okay, so what did we get? So basically, according to our experiments, we were able to estimate the tensile strength and the flexural strength of the materials. So these are the tensile strength values for the ones for the with and without carbon nanomaterials. So basically, if you look at this, the tensile strength and the flexural strength values are different than each other, and obviously this is because of the density of the carbon fibers. Because if you look at the carbon nanotube ones, and if you look at the difference between them, so the difference is not quite high. So these ones, for the tensile strength one, it is within the 5%. So of course there is an increment in the tensile strength and flexural strength, but it was not as high as we were expecting. So yes, depending on our study, we were able to obtain the tensile and flexural strength values, and so we can say that the tensile strength was increased by 7%, and then for the flexural strength was increased for like 5%. So it is still a good value, but so we might need to do some like adjustments according to that. And then again, according to the standard deviation and according to our test results, we can say that the experiments, the test results were quite similar to each other. And then so we can say that there was a good bonding between the carbon nanotubes and the epoxy, so there wasn't any problem within the manufacturing part. So actually this is just to sum up what we've done. And then for this study, actually, as I mentioned, so this is a quite preliminary study. And then after running some more experiments for the material properties testing, we are going to manufacture more specimens, and then we are going to investigate the fracture toughness values of these materials, because as I said before, the Epoxy was designed in order to minimize the delamination within the composite materials. So yes, we are going to check the delamination by doing some mode 1 experiments, DCB probably. And then we are gonna check for the mode 2 experiments too. And then we are going to run some low velocity impact testing at the beginning, and hopefully after that maybe high as well. And then so we are gonna run the SAM analysis in order to check the fracture behavior of it. And these are the references if you are interested, but I can pass you after that. And thank you very much for listening.
Okay, thank you for your presentation. I always give someone else questions. Yes.
Thank you for a nice presentation. Can you say something about the effect of the carbon nanotubes on the rheological properties? Have you done any measurement of viscosity? Is it increasing or?
So for the viscosity, actually it was increasing. So it wasn't the basic main of the study, but according to our investigations, yeah, it was increasing during the procedures.
Okay. But you said there was no trouble during the infusion process.
No. So basically, this it was increasing, but by heating the composite materials, we were avoiding the effect of that type of viscosity problems.
Yes. It will be interesting to understand how the SEM pictures and fractographic results will be. Sometimes you get some filtering effects, right? So
exactly. So that was the thing actually. So even the equipment that we have in our facilities, they were not able to pick up the quite nice SEM scannings. But hopefully with the impact testing, so I am a little bit more hopeful about it, but still we are going to try and we will see. So still it's not quite easy to pick up the photographs.
Thank you.
Thank you very much.
Yes.
What was your objective? Like how much strength increase, like tensile strength increase you want, or you're happy with these values?
So basically it was, as it is a quite preliminary research, and basically the increment rate is still within the theoretical part. So we are, of course, we are satisfied with the results, but obviously we are going to check if there will be any improvement points or anything, because we are trying to maximize the material properties.
Carbon nanotubes also comes with extra cost, and if you're just getting 3%, 5%, I don't know.
Exactly, that's the thing, because even for the 3%, 5%, 7%, so still we can, that's the thing actually, we can avoid the nanotubes, and then we can just use the different types of the density of the carbon fibers, for instance. So that's why it is important to know about the behavior of the material under the specific loading conditions, because again, like in some cases, carbon nanotubes can change the behavior, and it might be, although we get similar tensile and flexural strength values, but depending on the behavior, we might need to choose to go to the different density of the cloth, for instance, or different types of, again, like we might need to use the nanotube. So again, as long as we know the behavior, we might choose which one is going to be the cost-effective or which one is going to be the better one.
Okay. Thank you. Let's thank again our speaker.